So here we have 25 million persistent nematodes, which have been reared in wax moth larvae in a very low labor method. And while they don't look like it, you can actually see the nematodes on the side. And what we're doing here is capturing the wild traits that allow these nematodes to persist across times with no host, across winter, and therefore as a single application will last in the field for multiple seasons. Now the same species of nematodes are available in commercial. You can buy them in many catalogs. The difference is they've been continually reared and they've lost the genetics to persist. They typically only persist in the soil between 7 and 30 days. These particular wild ones, along with most wild ones, will persist in the soil without feeding for 1 to 2 years. In fact, this particular strain will survive in the lab for 2.5 years without eating anything at room temperature. So this persistence is how they actually get across no host in the field. The real issue with persistence is what we call phased infectivity. So what the wild nematodes do is there will be 100,000 new nematodes that come out of each one of these cadavers, and only less than 40% of them can immediately find a host and infect. The rest of them are in a suspended animation, and when their little clock, the clock goes off in their system, at some later point they become infected. So some of these in this cup will not be infected for a couple of years. Some of them are immediately infected. Okay, so the first thing we do is we just dump all this out. This is like these are actual wax worms, and they're sold in sawdust for the fish bait industry. And so this cup is actually sold for fish bait. When we inject in nematodes and they breed in here, there's 25 million nematodes in here. So the small infected nematode goes internal into the insect. They release a bacteria that they take with them. The bacteria actually kills the insect, dissolves its innards, and then the nematode, which only has sucking mouthparts, just sucks up all the nutrients and reproduces. And so it's a special relationship. The nematode releases a chemical to suppress the immune system. So with corn rootworms, the nematode goes in, suppresses the immune system, and the bacteria then duplicate. Where rootworm might develop resistance, like to everything else, it would be a resistance to that chemical that suppresses their immune system, and then the bacteria could overrun their immune system. Okay? So what we do here, the nematodes, 25 million nematodes are in the sawdust, on the sides of the cup, on the bottoms of the lids, until we generate about 20 gallons. And so what we're doing is flushing the nematodes out of the sawdust. Now, are we getting all of them out of the sawdust? Probably not. You know. And so typically when we do this over in the corner of the field or by somebody's garden, we throw all the sawdust, and then they probably get nematodes for the garden.